Saurabh, let's proceed ahead with your snap for strength of material for Engineers India Limited. So, Saurabh, can you tell me something about Poisson's ratio?
So Poisson's ratio is the ratio of the lateral strain on longitudinal strain.
What if both the strains are positive?
Sir, if both the strains are positive, then the ratio will be negative, and this is only in some special materials.
Okay, let me give you a plate, and you increase the temperature of that plate.
Yes, sir.
If you increase the temperature of the plate, its x and both by both direction the length increases.
Yes.
Can we say Poisson's ratio is negative?
No, sir. In this case, what will happen is that the thickness of the plate will decrease, so the Poisson ratio will still remain positive.
Tell me again.
I'll just switch off the fan. Yes. So even though the surface area of the plate will increase, but the thickness of the plate will decrease in this case. So the Poisson ratio still remains. The Poisson ratio still remains. Yes, sir.
Why thickness will decrease?
So this is to maintain the volume of the plate. So when we are increasing the surface,
increase the temperature, volume increases.
yes, sir.
Volume is not remaining same.
Yes. Sorry, sir. It will volume will change, but since the Poisson ratio is the inherent quality of the material, property of the material, so it remains positive, and thus the thickness decreases.
What are the other modulus of elasticity of material?
So one is the shear modulus, or also called the modulus of rigidity, and another one is the bulk modulus, and of course the another one is the Young's modulus.
How do you find out the modulus of rigidity?
So if we have the Young's modulus with us and the Poisson ratio, then with simple formulas we can find, or else we can find them by calculating the shear strain as well.
Suppose I give you a body sigma 1 is equal to sigma 2.
Okay.
What kind of Mohr circle will you draw?
Sigma 1 is equal to sigma 2. It will be a dots.
What is the maximum shear stress in that case?
The maximum shear stress will be the same as sigma.
Same as sigma. How?
Because if we plot the Mohr circle, we are not having any shear stress, so we'll point the coordinate of the point will be sigma comma 0 on the x-axis, and that will be the maximum strain as well, stress as well, sir.
Maximum shear stress I asked you.
Shear stress, it will be 0, sir.
Are you sure? But sigma 3 you are taking, what value of sigma 3 you are taking?
I'm considering it as 0, sir.
So take sigma 3 0 and draw the Mohr circle now.
Just
sigma 1 is equal to sigma 2 and sigma 3 0.
Okay. So the shear stress will be sigma by 2.
In which case shear stress will be 0?
In hydrostatic loading. Hydrostatic loading.
But if I take 2D body, then plate?
Yes, in 2D body and for 0 shear stress.
Yeah.
Just a minute, I'll draw the circle. So if we have biaxial loading with equal values of stress, then we'll have 0 shear stress.
Okay, now let me ask you, Saurabh. In case I give you a plate subjected to constraints from all the sides and I do thermal heating, simple plate of small thickness, subjected to restrictions from all the sides and subjected to thermal heating. Tell me the maximum shear stress induced in this particular body.
Just a minute. It will be, sir, mu times EA alpha delta T. Mu times E alpha delta T.
Mu. What is mu?
Mu is the Poisson ratio, and E is the Young's modulus, and alpha is the thermal coefficient, and delta T is the temperature change by heating.
E alpha delta T looks like a stress.
Yes.
So I asked you to calculate maximum shear stress.
Yes.
Why multiplying it with the Poisson's ratio?
Because if like for the one, because we are restraining it on 4 sides. So since we are not restraining on the z-axis, there will be no stress generated there. On the sides, if we take the formula, then when we take the shear, when we take the strain formula, sigma by E, for any of the directions of the plate, then we'll have the stress in that in the other 2 axes.
Tell me the 3 stresses. Can you tell me the 3 stresses induced?
Yes, sir. I think it will be E alpha T, E alpha delta T into 1 plus mu.
E alpha delta T, and another will be
1 plus mu, not mu.
1 plus mu. Stress.
Yes, yes. Yes.
You are saying about the stress in third direction.
No, sir. One of the blocked directions. In the third direction, it will be 0 because there is no restraint in the z-axis.
What will be the stresses in the 2 direction?
E alpha delta T into 1 plus mu.
Why 1 plus mu?
1 minus mu, sir. 1 minus.
Why 1 minus mu?
Because since it will try to expand in one direction, there will be opposite phenomena in the other direction. So the minus mu is due to, let's say if you're talking about the y-axis, the minus mu comes from the contribution of the x-axis loading, thermal stress.
Do you
And
think that is Poisson's ratio concept comes in thermal stresses also?
yes, sir, it comes like when we are restraining.
So it means when I increase the length of a bar because of thermal heating, its diameter decreases. Is that what you're saying?
Yes, sir.
Are you sure that happens in thermal heating?
In thermal heating, yes,
because
sir.
that happens when volume constancy is to be kept.
Yes, yes.
And in thermal expansion, volume is not constant.
Yes. Got it.
Okay, tell me something about Poisson's this bulk modulus.
Yes, sir. So bulk modulus is the ratio of the stress upon the bulk modulus is the ratio of the volumetric stress upon volumetric strain.
How it is related to compressibility?
It is a reciprocal of compressibility.
Reciprocal of compressibility. Okay, so what is the use of calculation of bulk modulus?
So in case of, let's say, hydrostatic loading, when we want to know the new volume due to the water pressure, then we use the bulk modulus to find the change in volume of the object.
Okay, which theory of failure will you use for copper?
So since copper is a ductile material, so we will use von Mises theory.
What is another name of von Mises?
It is a maximum distortion energy.
Okay, so Saurav, let me give you feedback. Saurav, you have revised, but somewhere you are making mistakes, small mistakes, very, very small mistakes, right? So try not to make those mistakes, and though you have revised this subject, and just prepare it again well. Marathon video you please do, strength of material. Okay. Marathon video, and go for as many snaps as possible, which are there, recorded snaps are kept on the panel. Right, so do as many as possible.
Yes, sir.
Right, because small basic mistakes if you do that, maybe they're creating trouble, right? Okay. Yes.